Let's practice graphing a sine function that has a bunch of transformations. If this function looks a little bit too complicated and you want to practice with some easier ones with less transformations, feel free to check out one of my previous videos on those as well. In this video, we're going to take a look at this function where we have f of x is equal to -1/2 times sine of the quantity of x minus pi over 2 plus 3. Here is our general form for the sine function, and we want to know what a, b, c, and d are. Rewriting this function so it's a little bit more clear to identify what these values of these letters are, we're going to have f of x is equal to this -1/2 in front. That's actually going to be our a value. That's going to multiply by sine of, and I'm going to use brackets here. This is going to be a b value over in front, so we just have a 1. So it's going to be 1 multiplied by what? We have 1 times x minus, and then we have a pi over 2. That's going to be c. I'm going to go ahead and close that parentheses. And then finally, we're going to have plus a 3 at the end, and that's going to be our d value. So in this function, a is equal to -1/2, b is equal to 1, c is equal to positive pi over 2, and d is equal to 3. Now that we know what a, b, c, and d are equal to, let's see what they tell us about this function. First, for the vertical reflection, this is a flip across the x-axis. That is determined by what the sine of a is, right? Now, since a is a negative number here, we know that this is going to be yes. There's going to be a vertical reflection across the x-axis. However, for a horizontal reflection, this is a flip across the y-axis. That is dependent on the value of b if it's negative, but you can see here b is positive, so we're not going to have a horizontal reflection or a flip across that y-axis. Now for the amplitude, this is how high or how low the graph is moving, and this is going to be the absolute value of a, which is the absolute value of -1/2, so that is just going to be positive 1/2. Because this value is less than 1, you can think of this as a vertical shrink. Now let's take a look at the period. The formula for finding the period of a sine wave is going to be 2 pi divided by b, but notice how in this case when we have this b value, that was this 1, so it's just going to be 2 pi divided by 1, and that's just going to equal 1, so our period is going to stay the same. It's going to take about 2 pi, or exactly 2 pi rather, for one cycle to be completed. So the period for this function is going to be the same period as the parent function. Now onto the midline. The midline is typically at y is equal to 0, but the d value is going to tell us if the midline is going to move or not. So you can see here that the d value is equal to 3 or positive 3. So the midline is going to shift up 3 units. We're going to say y is equal to 3, that horizontal line. Now let's go ahead and talk about the minimum y value and the maximum y value. For the minimum y value, that's going to be the midline minus the amplitude. So the midline is 3. Take away 1/2, that's going to be 2.5. So that's going to be the minimum y value. It's going to be positive 2 and 1/2. And then for our maximum y value, that's going to be the midline plus the amplitude. So that's going to be 3 plus 1/2, and that's going to be positive 3.5. All right, now that we figured out most of this information, let's take a look at our table and figure out when this whole thing is going to be starting and ending so that we can go ahead and start graphing. First, let's just remember our parent function. Our parent function is always going to start at the origin, then go up to 1, and it's going to go through the x-axis down to -1, and then back to the x-axis at 2 pi. So that's always going to start at 0, 0. At pi over 2, it goes up to 1. At pi, it's on the x-axis. At 3 pi over 2, it's down here at -1. And then at 2 pi, it's back along the x-axis. And so hopefully this is a review, but the x values for the parent function are going to be 0, and then pi over 2, pi, 3 pi over 2, and then 2 pi. And then for the f of x values, or the y values, it's going to start at 0. It's going to go up to positive 1, back to 0, down to -1, and back to 0. Now, while that's the parent function, let's talk about this function. So to go from these original x values from the parent function to these new x values, let's go ahead and take each of these x values and then add pi over 2. So we have 0 here originally, plus pi over 2. That's going to the right, so that's going to be now pi over 2 instead of 0. And then we have this pi over 2 over here. We're going to go ahead and add. Then we'll go ahead and take this pi over 2 and add another pi over 2, so half plus a half, that's a whole pi. After that, we're going to take this pi, add pi over 2, that's going to be 1.5 pi, or 3 pi over 2. Then adding 3 pi over 2 plus pi over 2, that's going to be 4 pi over 2, or just 2 whole pi. And then finally, 2 pi plus pi over 2, that's 2.5 pi, or we can write it as an improper fraction of 5 pi over 2. So to get from all these original x values from the parent function to these new x values, we just shifted them all to the right pi over 2 units because c was positive pi over 2. Now onto our y values. These are the original y values for the parent function, and the variables that are going to affect these are going to be the a value over here as well as the d value. These two variables will affect our new y values or f of x values. To get these new y values over here, what we're going to do is we're going to go ahead and take this original y value of 0, multiply it by -1/2, so 0 times -1/2 is still 0, plus 3, and that's going to equal 3. So we're going to multiply first and then add second. Then we're going to take this 1 over here, multiply by -1/2, that's going to be -1/2, plus 3, and that's going to be positive 2.5, or 2.5. After that, we'll take the 0 and we'll multiply it by -1/2, that's still 0, plus 3, that's going to be back to 3 here. Then take this -1 and multiply it by -1/2, that's going to be positive 1/2 plus 3, and that's going to be 3.5. Finally, we'll take the 0, multiply it by -1/2, add 3, and that's going to be 3. So I know that was a little redundant because the zeros here are all the same, so hopefully that makes sense. These are all the same as being 3s. Because we had a negative a value over here that caused this vertical reflection, notice how that we went from going up here to going down, then we went down while we went up, then we went down when we went up over here, and then we went up when we went down over here. So in terms of the direction that we're moving, everything is being flipped. Now that we know our x values over here, again, our normal start and end is going to be at 0 and 2 pi. Now we shifted to the right pi over 2, so the period is still 2 pi, so add 2 pi onto that, that's going to be this 5 pi over 2, that's where it's going to end. So here's the start and here's the end, here's the start and here's the end. Halfway through was this 3 pi over 2, so I'm going to put 3 pi over 2 in the middle, and then we have pi between those, and then 2 pi over here to the right. So again, the c value here of pi over 2 let us know that we were shifting to the right pi over 2 units. And this -1/2 for a and the d value of 3 caused a vertical reflection, a vertical shrink, and a vertical translation shifting up 3 units. Putting this all together in a very rough and quick sketch here before we do the actual one, the original parent function goes up, and then it goes down, and then it goes up just like this. But what did the effect of the c value of positive pi over 2? That just told us we're shifting everything to the right, so then we would have this new function over here to the right. Not only that, the whole thing needs to shift up 3 units, so you could go ahead and move this whole thing up 3 units, so it would look like it's over here. And then if you take into consideration what the a value is, it's -1/2. So because it's 1/2, it's actually not going to go up as much, and it's not going to go down as much, maybe something like this. And then finally, it is negative, so that's going to flip it. So it's actually going to go down first, then up, and then down. So that might be a little confusing, which is why I'm going to go ahead and sketch the detailed one down below. But hopefully that kind of helps you see that the resulting function here is going to be higher. It's not going to go up and down as much, and it's going to be completing one cycle somewhere up here. Now let's go ahead and actually graph it. Feel free to scale your graph however you would like to, but this is how I'm going on mine. I'm going by pi over 2 along the x-axis and going by 1 whole along the y-axis. For our first point here, we have pi over 2 comma 3, so that's to the right pi over 2 all the way up to 3. Maybe I'll put that right here. Then we have pi comma 2.5, so I'm going to go to the right pi and then go up to 2.5. That's halfway between 2 and 3. Then we have 3 pi over 2 comma 3, so go to the right 3 pi over 2 and go up to 3. And then we're going to have this 2 pi comma 3.5 pi, so let's go to 2 pi and then 3.5. That's up here between 3 and 4. And then finally 5 pi over 2 comma 3. Go to the right 5 pi over 2 and then back down to 3. So putting this all together, making a rough sketch of a curve, it looks something like this. If we continued this pattern to the right, it would go down, then back to the middle, then it would go up. And continuing the curve, it might look something like that. And then continuing it to the left, we would go up, then back to the middle, then down, back to the middle, up, back to the middle, down, to the middle, then up. This would be graphing a few periods of this function. And just in case you were curious, our midline is over here at y equals positive 3 because that positive 3 value for the d. Our maximum y value is going to be halfway above here just because we had an amplitude that had an absolute value of 1/2. And our minimum y value is going to be down here. That's just halfway below here, just because our amplitude again is 1/2, so it's going to go up 1/2 and down 1/2 from the midline. Here you can see that amplitude going up 1/2 over here and then down 1/2 over here. All right, so there you have this graph of this sine function. Again, this sine function had a bunch of different transformations going on here. So just to recap very, very quickly, this -1/2 told us that we did have a vertical reflection as well as a vertical shrink. It got compressed by a factor of 1/2. The b value of 1 told us the periods is going to stay the same as 2 pi, no effect. This pi over 2 for c let us know that we're shifting to the right pi over 2 units. That affects the x values. And then this +3 at the end for d lets us know that our midline shifts up 3 units. And it also tells us that all our y units are going to shift up 3 units as well. So if you found this video helpful, please consider giving it a thumbs up and feel free to share also with maybe a classmate or friend who might find it helpful. You can also find a link in the description below that has a blank PDF as well as this annotated answer key if that's helpful to look at afterwards. So keep up the great work that you're already doing, and I'll see you in the next one.